We're going to look at some different kinds of quadratic expressions. So you need to realize that even though this only has two terms, here's a term and here's a term, that this is still a quadratic because our highest degree is 2. So if we have a highest degree of 2, that means we have a quadratic. So when we look at a quadratic in standard form, we think of ax squared plus bx plus c. So if we were to line these terms up underneath our standard form, we would have 7n squared, because this is a squared term. There is no variable here, so this would be minus 21. So in some cases, this will become a special kind of factoring, but for right now, we're going to look at it in this format. So of course, the first thing that you need to do is you need to factor out the greatest common factor. So what is our greatest common factor between 7 and 21? Well, it's 7. So that means I can factor out a 7 from both terms, and I end up getting x squared minus 3. So let's try to factor this n squared minus 3. In order to do this, the way that I've been showing you is we need to have our center term. And right now we're missing a center term, which means we have no x term. So that's 0x. So this would be plus 0x because we're missing a center term. 0 times x is 0, which makes that middle term go away. So now we're going to go ahead and we're going to factor n squared plus, excuse me, that should be an n, not an x, because we're using an n term, 0n minus 3. So we're going to go ahead and we're going to set this up. And we're going to look for our factors of our first times our last term, and we get negative 3n squared. And that needs to add up to 0. So if we're looking for our factors of n, we know that's n times n gives me n squared. But let's think about our factors of negative 3. So I have 1 times negative 3, or negative 1 times 3. So either way that I add these up, I will never get to 0. So that means that I can't factor. Okay, so that means that the factored form would be, don't forget our 7 that we factored out in front, 7 n squared minus 3. So this here is our factored form of the quadratic. So let's look at something similar but different. So in this case, I have 3x squared plus 12x. So again, do I have a quadratic? Yes, I do. Right here, I have a quadratic because my highest term is 2. I also have two terms. I have a term here, and I have a term here. So when I think about my standard form of a quadratic, it's ax squared plus bx plus c. If I align these underneath my standard form, my x squared term comes first. This is an x term which comes second. And then this here is actually a 0. It doesn't exist. So when we compare the two, the one we just did and this one, we notice they're different. This one has a middle term, this one does not. This one does not have a last term, this one does. So be very careful between these two different kinds of factors. So just like we did in the previous problem, I have a greatest common factor. I'm going to look for that first. So my greatest common factor between 3x squared and 12x is going to be 3x. That means I'm going to divide out a 3x in this quadratic here. So remember, that's the same thing as dividing out. The 0 is not adding any value to anything, so I don't need to worry about that, although I could, just for the sake of continuity. I can still factor that out, and I'll show you what will happen. So 3x squared divided by 3x gives me x. 12x divided by 3x gives me 4. And 0 divided by 3x gives me 0. So I can combine my 4 and my 0, so then that gives me 3x times x plus 4. Notice there is nothing squared here. There's nothing squared anywhere, so this here is my factored form. And I'm done with that. So you need to know when you stop and when you need to keep going. In the next video, I'm going to show you when you need to keep going.